Planetterrian Daily, episode EI84, coming to you on June 9th, 2026. Let's get into today's research and health developments. A genomic analysis of koala populations reveals that the species experienced a pronounced contraction in numbers roughly 100,000 years ago. The timing of that decline sits well before any human presence on the Australian continent, which forces a re-examination of long-held ideas that attributed the animal's demographic challenges primarily to later human activity. Because the contraction predates those influences by such a wide margin, conservation planning may need to weigh ancient bottlenecks alongside more recent pressures when setting recovery targets. Additional genome sequencing is already scheduled to trace subsequent rebounds and further dips, which should give researchers a clearer map of how the population has responded to environmental shifts over deep time. That longer view matters for understanding whether today's fragmented groups carry genetic legacies from that early event, or whether more recent changes dominate their current trajectory. Moving from a single species demographic past, it helps to step even farther back and consider how reproduction itself first took shape among animals. Fossil and genomic evidence together indicate that the earliest multicellular organisms relied exclusively on asexual reproduction for millions of years. That mode of copying limited the introduction of new genetic combinations and kept the pace of new species formation comparatively slow. Later, environmental pressures appear to have favored the emergence of sexual reproduction, and once that mode became established, the rate at which new lineages appeared rose sharply, roughly 10 times higher than before. The same tightly controlled meiosis machinery that now operates across all multicellular life still carries the imprint of that ancient transition, which suggests the change was not simply an optional upgrade but a foundational reorganization of how genetic information is passed forward. One practical consequence is that any modern effort to reconstruct deep evolutionary trees must account for the fact that sexual reproduction accelerated diversification long before the lineages we study today even existed. From those ancient shifts in how genetic material is shuffled, recent work turns to present-day influences on cellular signaling that may also shape long-term health. Observational data link higher adherence to a Mediterranean-style eating pattern with elevated circulating levels of the mitochondrial peptides humanin and sh-Mus. Among the individual components, olive oil, fish, and legumes showed the clearest associations with those peptide concentrations. Humanin levels in particular moved in the opposite direction from markers of oxidative stress, hinting at a possible pathway through which steady dietary choices could modulate mitochondrial communication. If those associations hold up under controlled intervention conditions, the peptides could function as practical indicators of how well a given eating pattern supports mitochondrial function. That possibility fits into broader efforts to find reliable, measurable readouts that reflect mitochondrial status as people age, rather than relying solely on downstream clinical outcomes. The same interest in how everyday exposures accumulate over decades surfaces in a recent Lancet series that draws together biological mechanisms, population-level patterns, and prevention perspectives spanning prenatal development through later adulthood. The papers lay out how influences encountered early in life can compound with subsequent experiences to shape clinical trajectories, and one of the figures maps the layering of those exposures across the lifespan in a single visual summary. The emphasis throughout remains on describing the cumulative nature of risk rather than proposing any novel interventions. What stands out is the reminder that windows for influence are not confined to any single life stage. Instead, the data illustrate how prenatal conditions, childhood environments, and adult behaviors each add measurable increments to later disease burden. That integrated framing encourages researchers to design studies that follow the same individuals across multiple decades instead of isolating single periods. Building on the idea that modifiable behaviors contribute to lifetime risk, another analysis examined alcohol intake in relation to several major health endpoints. Consumption below 1 drink per day already corresponded to higher rates of cancer incidence, cardiovascular events, and earlier mortality in the cohorts examined. Those associations strengthened further as intake rose above 1 drink daily, with 2 drinks per day linked to noticeably higher alcohol attributable death rates. The study relied on cause-specific outcome tracking across large population samples, which allowed the investigators to separate effects on different disease pathways. Because the elevation in risk appears even at levels often considered low or moderate, the findings underscore the value of capturing fine-grained dose information when estimating population-level impacts rather than treating anything under a certain threshold as neutral. Taken together, these threads, from an ancient genomic bottleneck in koalas through the evolutionary invention of sexual reproduction to contemporary dietary associations with mitochondrial peptides and the compounding of lifetime exposures, illustrate how both deep history and daily choices leave measurable traces in biology. Next time, keep an eye on results from planned further sequencing of koala genomes that could map additional population recoveries and contractions. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.